Math 1343, Week 3, Video 1, Estimating One Population Mean. Last week, we reviewed estimating one population proportion and estimating the difference in two population proportions, both of which were confidence intervals that essentially followed the same four steps. We just had to make a slight change. We just had to make a slight change in how we calculated the standard error and how we built the final confidence interval, the point estimate around it, which is centered. What I'd like to do in this video is first draw a straighter line here. There we go. Well, what I would like to do in this video is quickly review the four steps for building a confidence interval for P and show you how those steps are similar and different to building a confidence interval for mu, a population mean. The four steps for building a confidence interval for P, the first was to find find Z. And this was find Z using the confidence level. I'm going to put CL for confidence level. A reminder, we drew a bell curve. The confidence level represented the center area, and then we used the Z-chart to find the Z-scores that cut off those two tails. Second step for finding a confidence interval for P was to find the standard error. And the formula for the standard error was the square root of a fraction. Top was P hat, the proportion of a sample that had a characteristic, times 1 minus P hat. That was all over n. The third step was easy, and in general, the third step of finding a confidence interval is to find the margin of error, which is almost always found by multiplying the first answer times the second. And then our fourth and final step was to actually find the interval, and the interval estimate was built off of the point estimate. The point estimate for P is P hat, but then we did plus or minus a margin of error, open up an interval around it. So those are the four steps that we did when we built a confidence interval for population proportion, for P. So how do we adjust these, build a confidence interval for mu? Well, some of the changes will be obvious, but some of them won't be as obvious. For example, in the fourth step is going to be the same. The way you build a confidence interval for a population parameter, in this case mu, is you center it around the corresponding sample statistic, the point estimate, if you will. The point estimate for population mean is sample mean. The variable for sample mean is x bar. So when we get to the end, interval will be centered around the sample mean, but we'll still add and subtract a margin of error to it. First three steps are mostly similar. There are some subtle differences. For example, when we're finding confidence interval for mu, we're not going to use the Z-chart. We're going to use the T-chart. We're still going to find it using the confidence level, meaning that we'll draw a bell curve and put the confidence level in the center of the bell curve and find the T-scores that cut off the left and right tails. I'm going to draw that T a little bit better. But being the T-chart, we have to have something for the degrees of freedom. Degrees of freedom, abbreviated DF, when estimating mu, is just lowercase n minus 1. In other words, the sample size minus 1. And we'll illustrate this in the next video. The second step is still to find the standard error. But clearly, we're going to need a different formula, because the previous formula, confidence interval for P standard error, involved P hat. Well, if you're talking about means, there are no proportions, so we can't use that formula. But the formula for this one's pretty easy. It's S square root of n. Just a reminder, lowercase s is sample standard deviation. Your third step, finding the margin of error, Although the formula is slightly different, the premise is exactly the same. To find the margin of error, you just multiply the first two answers times standard error. So for the most part, well, maybe not for the most part, but there are a lot of similarities between building a confidence interval for mu versus a confidence interval for p. On the first step, we find t instead of z, which means we need a degrees of freedom. Our second step is still to find a standard error, but it's a different formula. Our third step is to still find a margin of error, and it's essentially the same formula, just with t instead of z. And then our fourth step is to build the interval around the point estimate, but because we are estimating mu, population mean, then the point estimate is sample mean, or x bar. We'll do a couple of examples in the next two videos, but to be honest with you, building this confidence interval is really, really